So far you've learned how to solve triangles using the law of sines, and that's for specific cases. That's when you had, I'm just going to make a note right up here, angle, angle side, or angle side angle. And then it also could have been used for side side angle. But the law of sines doesn't work for every triangle. Side angle side and side 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 both would use the law of cosines. So side angle side, side 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 both use the law of cosines. And the law of cosines is, it's all of this. It's still the same thing where if this is A, using opposite sides with the angles. So B, this is B. C, hey, the opposite side, that's going to be C. It's just the equation's different. Now instead of writing ratios, we're writing equations to find the missing side lengths. So if I want to solve for A, I would use this equation. If I wanted to solve for B, I would use this equation. If I want to do C, I'd use this equation. We could also solve for A, B, and C, but doing that, we'd use inverse trig, and lucky for us, we already know how to use inverse trigonometry. We talked about that a little bit in your 10.4 notes, and you're going to see how to plug it in your calculator in today's notes. So this right here is just saying, hey, use it for side angle side and side side side. Side angle side, just a little side note. If these are my two sides, side angle side has an included angle, so we would want to use this angle right here. So that's what side angle side looks like. Again, an included angle because it's in between the two sides. And then side, side, side is pretty clear. You just have the lengths for all three sides. All right, now we're going to try example 1. I honestly should have given you more space. I kind of forgot how much space this could take up when I was making the notes. So I'll try to remember to change the format before I post it or make copies on Monday. But for now, I'm just going to use this sheet of paper here to extend my work while making the video. When we are solving a triangle, we still want to find all of the missing lengths. Now here I see I have two sides and an included angle, meaning this is side angle side. Side angle side uses the law of cosines. So all of these equations that I mentioned above solve for the missing lengths, the easiest. Again, we could solve for the angles, it's just not the easiest thing to do, but it is possible. So I want to solve for length B, meaning I'm going to use the equation that has B squared equals. So I'm just going to go ahead and write the rule. So this is my step 1. B squared equals A squared plus C squared minus 2AC cosine of B. So if I'm wanting to solve for B, it's just going to stay B squared equals A squared. So if this is angle A, this is side A. Oops, let me scooch this down. Again, if this is angle A, this is side A. So I'm going to do 7 squared plus C squared, which is the side length. So if this is angle C, this is side C. So that's 5 squared minus 2 times A, which we said was 7, times C, which we said was 5, cosine of angle B. So angle B is 100 degrees. And all we have to do is clean this up a bit. 7 squared is 49 plus 5 squared is 25 minus 2 times 7 times 5. So that's going to be 70, and then cosine 100. Okay, I'm just pulling up the calculator, clearing it all off, and I'm going to show you how to plug it in. So we can go ahead and just plug in this whole expression. I could have plugged it in earlier, it's just that this was a bit easier. I have 49 plus 25 minus 70 cosine 100. And I always like to close that parentheses, showing I'm just taking cosine of 100. I get 86.15, so it says round to the nearest tenth, meaning I'm going to write b squared is approximately 86.2. But this is not our final answer. Okay, I wanted to solve for length b, not b squared. So I need to take the square root of each side. Technically, whenever we take the square root, we should put a plus or minus out front. But since I'm dealing with a length, it can't be negative. So I'm just going to put the positive solution. Square root of 86.2. I get approximately 9.3. So I've just found this length right here. But I'm still missing A and C angles. So I do need to solve for that. Honestly, you can pick whichever one you want to solve for first. Let's just do A, just because I want to. Okay, I could have picked either one. So after step 1, which is finding the missing side, I'm doing my step 2, which is solving for the next thing. And we said we're going to do A. So if I want angle A, when it comes to which equation I use, I want to use the one with A. Okay? So if I would have picked C to solve for, I would have want to use this equation right here. I'm just going to rewrite the rule real quick to help us. It's a squared equals b squared plus c squared minus 2bc cosine A. A, the length is 7, so it's 7 squared equals b, which we just found. That's 9.3 squared, plus c, which is 5, so 5 squared, minus 2 times b times c cosine A. So you can see that because we knew all 3 side lengths, all of these are numbers, and I'm solving for this variable here, which is what we're taking the cosine of. So let's just clean this up. I know that 7 squared is 49 equals, I'm going to do 9.3 squared. I get 86.49 plus 25 minus 2 times 9.3 times 5. That's 93. Cosine A. I'm going to keep cleaning this up. So the goal is to get A by itself, but we're taking the cosine of it. So let's get cosine A by itself. It's currently being multiplied by the negative 93, but I can't get rid of that yet. I'm going to have to add these together and move it over. So if I do 86.49 plus 25, this is going to give me 111.49. So it's positive. If I want to bring it over to the other side, I'm going to have to subtract. So that's gone. And 49 minus 111.49 gives me a negative 62.49. So you can already see we're not going to be getting very nice numbers. Okay, so now I have cosine of A. It's almost by itself, but not quite yet. It's currently being multiplied by negative 93, so I need to divide. Okay, so I'm just going to go ahead and plug this into my calculator. I get 0.6719. It keeps going. I just put a few because the more you put, the more accurate your final answer will be. So I'm trying to get cosine of A by itself, and I did that now. I'm trying to solve for A. You cannot just divide by cosine. We are taking cosine of A. If you were to divide by cosine, you'd do cosine of A, and then it wouldn't work. This would become 1, and then we'd have to, you know, try solving for a all over again. That's called circular reasoning. It's not going to happen. To undo cosine, we have to do its inverse. And we learned in 10.4 that the inverse of cosine looks like this. So inverses undo one another. When we had positive, we had to subtract because that's negative. That's the opposite. When we were multiplying, in order to get cosine of A by itself, we had to divide because that's the opposite. If I have cosine of A, in order to get A by itself, I have to take the inverse cosine. But what you do to one side, you have to do to the other. So these cancel out, and I'm just left with A. And over here, I have cosine inverse of 0.6719. So I'm going to plug that in. Cosine inverse of 0.6719. A is approximately 47 point, it did say round to the nearest tenth, so 0.8. I'm just going to show you what that looks like. 47.8. Now I'm going to show you what it looked like when I plugged it in my calculator, because I'm not sure if you all have messed with it too much. You can see on a TI-30X we have sine, cosine, tangent. If you want inverse of any of these, all you have to do is hit second first. So I wanted inverse cosine, so I hit second cosine, and you can see it says cosine inverse of, and then I just put 0.6719. And I got 47.78, but the 8 boosted the 7 up to an 8, so 47.8. Now this is an angle, so I'm going to put degrees. And the third step is actually a little bit easier. Let me go back up here and write in the other length we just found. So now we need to solve for angle C. We could use this equation and solve for C using inverse trig all over again. That is an option, and you are welcome to do that. Or we know all triangles sum to 180 degrees, and I now have 2 of the 3. So to find C, all I have to do for C is to do 180 minus the 2 measures we now know. So 180 minus 100 minus 47.8. So 180 minus 100 minus 47.8, I got approximately 32.2 degrees. I'm going to go ahead and stop the video here and then show you this next example.